All right, so what I wanted to do here is give you help with one from each page. This is what you're going to be working on today, and then a little bit on Saturday as well. It's going to be due Saturday, right? So we're going to look at 5, 7, and 9, I believe, and you're going to be responsible for 6, 8, and 10. So 5 is, again, similar to what we were looking at yesterday. And if you are struggling, make sure you check out the key in the other video that was posted earlier today. All right, so again, we're going to look at this. We start from position -20. So we're going to start way down here in this position graph. All right, and we stay at rest for 5 seconds. Slope is velocity. If we're staying at rest, we have no slope. So the line is flat down here for the first 5 seconds. Then we walk back at a constant rate. So we're moving. We have a constant rate. So that means we're going to have a line. The line is going to have a slope that doesn't change or is linear in nature. And then we accelerate positively for the last 5 seconds. So again, we're going to have a slope, but in this case, because we're accelerating, our slope is changing. So we're going to curve for the last 5 seconds. You could also curve, this way as well. Either way is fine. So what does that look like now for a velocity time graph? Well, starting at position 0 means nothing for a velocity graph. What we do know is that we're not moving for the first 5 seconds. If that's the case, then our velocity for the first 5 seconds is 0. We're not accelerating or moving. Okay, then we're walking back to position 0. This throws people off. Again, position doesn't mean anything, but we're walking with a positive constant velocity. So now our line is just up here. And you can connect them with like a little line if you want. So that's part 2, is this line above the x-axis that's flat. And then we accelerate for the last 5 seconds. So now slope is acceleration. We have a slope, and now we have that. So again, at rest is the first flat line, positive constant velocity is the second flat line, and then positive acceleration is the third line. So 6, same idea. All right, 7. So you're going to draw, ignore the part that says the acceleration time graph, that we can ignore. Okay, so draw the velocity time graph. Actually, no, let's do both. Draw the velocity time graph and then the acceleration time graph for what's going on in this one. So you have to say, all right, you got to ask what's going on. So let's just do a brief write down of exactly what's occurring here. So here we have a slope. We know slope is velocity and our slope is going up. So the first part, this is a positive constant velocity. Here we have no slope. Slope means velocity. Since there's no slope, this is at rest. Right? And then this part is the opposite of this first part. So we have a slope, it's negative, it's not changed, it's a negative constant velocity. So now we can graph that right over here. Positive constant velocity, no acceleration, that's a flat line here. Right, at rest, that's a flat line at 0. Negative constant velocity, that's just a flat line below 0. Okay, now 9, oh, I forgot to do this part, the acceleration part. Okay, this one's super easy. So real quick, let's just label this again. So this was positive constant v, this is at rest, this is negative constant velocity. We drew this, it looked like this, then here, then here. Okay, this whole time, we're not accelerating really. The only thing you could say is we have no acceleration. And then if you really wanted to, I'm not going to have a big deal about this. For this first part, when you go from moving to stop moving, you have a brief negative acceleration, then back to 0. And then here, when you're at rest and you start working backwards again, you have a very brief negative acceleration and then to 0. You could also draw this line if you wanted to. All right. Like this. Look how easy this part is. We can just do this. No acceleration at all. All right, either one is fine. All right, last but not least, all right, so now we're going to go do the same thing, but we're going to use a velocity time graph. So again, let's identify, hey, what's going on in the graph and then work backwards from there. So here we have a slope. We know slope is acceleration. all right? And it's positive, so this is a positive acceleration. And here we have no slope, we don't have an acceleration, but we are above the x-axis. This is a positive constant velocity. So let's first graph our position. Okay. So we have a positive acceleration. It doesn't tell us where to start. So as long as for the first 10 seconds, our line is going up and is curving, you're good. That's our acceleration. And then positive constant velocity, linear afterwards. Curved and then linear. Okay, and then to show it here, okay, in this part, we have a positive acceleration. So we said for these, our lines are always going to be flat here. So this first line is flat for the 10 seconds. That's a positive acceleration, and then 0 acceleration.